So I'm doing this video because I want to teach people how to make a Shiny app that utilizes async promises and that is able to kind of connect to a database and do it really efficiently and use modules and all of that stuff. So primarily use modules and utilize async promises, which are two things that I didn't find quite easy on the internet with documentation, and I feel that could be explained in a video much more simply. And since I'm doing it here with an actual project, like a small project, for example, I think it's going to be easy to grasp. So what I'm going to do is I'm going to do a polling site thingy that sends data over to a Firebase real-time database. And yep, that's pretty much it. And that you can like look at some stats from the polls. I think that's an easy project, and I think that I can explain most of the things utilizing that schema. So I'm gonna call this polling. It's just gonna create this. I'm gonna open a terminal tab. So right here I'm inside that folder. I'm gonna create a couple files. I'm gonna first create my R environment. No, actually first, I'm gonna create my R environment file, and I'm gonna go on Google Chrome, and I will go on firebase.google.com. Cool. I'm gonna restart my window manager. So right here, I'm gonna go to the console, and I will create a project. So my project test, continue. Enable Google Analytics, yeah, why not? My only account. So it's creating the project right now. The things that I do right here can be applied to any database, not only Firebase, just that Firebase is really quick. Postgres or any SQL relational database should work in a similar fashion. However, sometimes the authentication, the connection with the drivers doesn't work that well with asynchronicity. So perhaps working with a RESTful API like Firebase does is much more convenient. Okay, so now once that I have my project created, I have to create a web app. So I click here, web. I'm going to call this polling. Just going to register the app, and it's going to give me an API key. Here, the API key. Cool. So I'm going to copy that, and I'm going to put it in my R environment. So I'm going to just call this API key equals this. Perfect. And my project URL, I think it's this one's the auth domain, but I'm not sure. So I'm just going to continue to console and go directly to our real-time database. So here on the real-time database, I'm going to create a database. United States Central is fine. In test mode, I'm not going to enable authentication. That would be on you, but I'm just going to go testing mode because that's the quicker thing that I can do right now. So I'm going to copy this link. I'm just going to call this db URL. I'm just going to paste it there, and I'm going to save this. Cool. I can close the terminal now, and I can go on to RStudio and start a new project. So just quit RStudio. Yep, don't save. And I'm going to start a new project. New project. Okay. New project. Let me create a new project. There you go. Existing directory. I'm just going to go on my desktop, projects, polling, open, create a new project. It should have read my R environment file. So let me sys.get environment API key. Good. So I actually read it, and now I have my API key loaded. So now I'm going to want to create my Shiny app. I'm just going to go directly here and create a Shiny web app. Multiple files. I'm going to call this temp because I'm going to move both files to my master directory. And then I'm going to delete that folder because I just want it to be on the main, not copy to, move to, there you go, right here. Yeah, it's going to tell me that it's deleted. There you go. Now I can delete this temporary. Okay. Cool. So on server and UI, I'm going to delete everything that's in here. I don't need it. I'm going to delete even the Shiny. The Shiny library because I'm going to load that on my global.environment, my global.r file. So the global.r file basically executes everything before the Shiny app starts, which I think it's much more convenient for what we're going to do right here. On other use cases, it might be different. So right here, we're going to have to load the libraries that we need. So library, Shiny, we definitely need Shiny. We're going to need Fire Data, which is a library that takes the Firebase API and puts it into R right here. So it's this project. You can visit it. Works pretty well. So I'm going to use Fire Data. I'm going to use Shiny. I'm going to use Promises and Future because those libraries let me create promises and future. And there you go. This should be enough. So I'm going to create an R folder. I'm going to tell the global.r to source every single file inside the R folder. Since this is not a library, everything in there we're going to want to read as scripts. So I'm just going to lapply to list files inside the R folder. And to it, I'm going to execute the function source paste 0 r/x. So this line should source every single file inside of the R folder. So in the R folder, I'm going to create a new script. I'm going to save it. I'm going to call this Fire Data functions. So let me just, or upload database functions so that I know what they're about. So why am I creating extra functions? Fire Data brings the upload function and the download function. Let me zoom in a little bit just so that you guys can see a little bit clearer. So the thing about the upload and download functions is that they have this particular thing where if you upload, you're uploading a whole data frame. Let's say you have only one response, it would upload the one response, it's going to be quick. But if you add multiple and multiple and multiple, it's going to get bigger and bigger and bigger, and it's going to become really, really inefficient. So something I've figured out with the databases is that if you actually upload a list under a directory, you can make the library think it's a data frame even though it's not. So I'm going to give you an example. First I'm going to load library Fire Data, there you go. And I'm going to upload. I think first I need, I don't need a token since I'm in testing mode. But first I need to enable anonymous login before doing this example. So I'm going to enable it here, save. So now if I do upload x empty cars, and the project URL will be sys.getemp. How was that I called it? I didn't call it URL, nor project URL. I called it dv URL, okay. dv URL. If I execute this, I'm going to get a file here on my real-time database. well, not a file, but a directory under main. That's all of this. And this directory has basically subdirectories that have like row, so this is how it's structured. So you see there's a directory, and in each directory, the index of the row has the values labeled. So if I do, instead of upload empty cars, I upload a list where column A is equal to 1, B is equal to 2, and C is equal to 3. And I put directory main/testing. If I do this, you're going to see it's going to be main testing and then this whole thing. If I do this over and over, let me just run this twice more. Here on Fire Data, I'm going to get again main, a directory, and it's the same structure. So now if I download testing, so if I use the function download sys.getEnv dv URL, and the file name, I put main/testing. If I run this, it's going to give me a list, and each one has like values, right? So if I bring the library data table, and I use rBindList, this function, and I nest this in here, it's actually going to bring me a data frame with the values that I want. So that's why I'm creating new functions. So my first function is going to be upload row. I'm going to call it like that. Upload row is going to be function of, again, X project URL, so that I can like keep consistency, and a file name, right? Right here, it's just going to be upload X equals X, project URL equals project URL, and the file name I'm gonna equal paste0. So I know it's gonna be under main, so it's just gonna be paste0 main / and file name. Cool. So now if I do upload row and wanna X equals list, A equals 1 and B equals 2. Under the file name results, unused argument file. Oh, it's directory, right? My bad. Directory. So now if I re-execute this, what do you mean? File name. Project URL file name. Oh, I forgot to put the project URL. Sys.getEnvironment dv URL. There you go. It's gonna do exactly what I did here, but it's just gonna be much easier on the app to have clear code. And now I'm gonna add a function download. Download to, I could set it, or download df as download data frame. It's going to be, again, function. I can literally copy this. And here what I'm going to do is going to do rBindList, and the list will be download project URL will equal project URL, file name will equal, again, paste0 main/file name, and that should be it. There you go. So now let's download results. So I just need to change this to download results. Oh, I don't need X right here. If I do download download df, take out X. There you go. It brings a data frame with what I wanted to have. Cool. So now I can actually start working on my Shiny app. So I'm going to delete all of this. I don't need it right now. And I'm going to create a Shiny module. So we could just work on top of UI and on top of server. But modules let us divide our code in different parts, which I think is really useful. Usually I would create a modules folder, but in this case, I'm just going to put it in the R folder. Changes nothing. So I'm going to call this poll, just poll.r. Here I'm going to create poll UI, which is going to be a function of ID. And I'm going to create poll server. It's going to be a function of, again, ID. Cool. So here I'm going to build the UI. First, I need to create like a namespace. The function ns, if I put anything in here, let's say test. I haven't brought the Shiny library, right? No, I have not. Let me put this read data at the table here too. Let me just load all of this. There you go. So now if I put ns, it's going to return a function that I can use to create a namespace. So cool. Let me here ns. And here I'm going to bring a tag list. So here I'm going to build my actual UI. So I'm going to create a fluid row. And I'm going to make it really simple. I'm going to ask for a name, an email address perhaps, a name, a last name, age, height, and favorite color. I think that's going to be okay. Cool. So fluid row. I'm going to make this into two columns. Column with equals 6. And here column with equals 6. And here I'm going to put a text input. Input ID will be ns. So I'm going to use the namespace. Text input, this will be name. I can actually just put full name so that I don't have to add another. So name, this will be full name. Cool. Now I can have a numeric input, which is ns age. It's going to be age. Another numeric input. This could be height. And on the other column, I'm going to put select size input. Input ID will be color. So this would be like your favorite color. So favorite color. And I forgot a comma here. I'm going to put this down so that I have a little bit more space for the choices. So choices, I don't know why it's not completing. What did I do wrong here? Value, I need to add a value, right? Value equals 0 and value equals 0. Okay, so I don't know why it's not options. I think it's choices. I'm just going to go for choices. If I'm wrong, well, I'm just going to put red, green, and blue. Green and blue, the RGB. And blue. Cool. And I'm going to add like a comment section. So text area input. Input ID. I'm going to put that. Comments. And width equals 100%. I need to add a label comments. I think I'm going to need a label here because I didn't do it in order. Cool. So now in the UI, I can go right here and actually just put pull UI main. And if I run the app, there you go. I have my UI. Perfect. Cool. I forgot a submit button. I need a submit button. So right here, action button, submit. Cool. So this works now. Now I need to, on the server, I need to call it something. So I'm going to call module. You could usually use call module directly on the server.r, but people say that's like the old way, so I'm just going to use it directly with call module. Or there's like module server, which I honestly don't I don't understand much of the difference. So I'm just going to go for module server. So here ID will equal ID, and the module, it's supposed to be a function. So the function is going to be a function of input, output, and session, like you do on the Shiny server. So I'm going to put server right here. It's a function of input, output. I'm going to add session right here. Session, there you go. So yeah, it's just a function for the Shiny server. And here I'm going to put a couple things. So first I'm going to add an observe event to send the data. So observe event is going to observe the event input submit. And on submit, I'm going to do a couple things. I'm going to save all of these values into actual variables, not reactive values, because these are inputs, outputs, etc. And if I try to put those into a future, it's not going to work. So I'm going to put name is going to be equal to input name. Age is going to equal input age. Height will equal input height. Color will equal input color. And comments will equal input comments. Cool. And I can add like a time, which is going to be sys.getTime. No, time. Sys.time. That's going to be good. Cool. So now I can use the functions I created right here to upload that data. But we want to do it inside a feature. So what does the feature do? It executes whatever we put in it on a different thread, like on a different R session. Here, actually on the global, I need to put another thing that's plan multi-session. So it uses multiple sessions in parallel to actually execute those commands inside the feature. So here I'm going to call a feature. And here what I'm going to do is upload, in this case, upload row. So X is going to be a list where name, name is going to be equal to name. Name is going to be equal to name. Age is going to be equal to age. Height is going to be equal to height. Color is going to be equal to color. Comments is going to be equal to comments. And time is going to be equal to time. Good. The next argument is going to be the URL. Yeah, the project URL. So the project URL, actually I need that in another URL. It's going to be equal to sys.getEnvironment db URL. Cool. So here project URL is going to be equal to URL. And file name, I'm going to set it to polls. Cool. So now this should execute another R session, which is pretty cool because it won't lag. Like in case Firebase takes a long time to give a response, which can happen, or if the internet connection of the main server is not that good that it takes a long time to actually get a response, it's not going to lag the user doing the poll. And this, usually REST APIs are really good in features, and this can help a lot when scaling Shiny apps. So that's something important to take in mind. So now I need to add poll server into my server.r. So now poll server, and the ID is going to be main, right? Here I used main as well. So let me run this. And if I'm not wrong, this looks kind of ugly because it's really big. So here, if I put Andres, which is my name, 18, my height is 180, and perfect, and I submit. Here on my fire data, I should see my input. Perfect. So now I'm going to actually work a little bit on the UI. So I'm going to put here a fluid row. I'm going to put a column width equals 6, and I'm going to put the poll UI here. And I'm going to make another module. I'm going to column width equals 6. I'm going to bring another module that reads out the results. And that module is just going to be a simple data table that brings the results every 10 seconds, every 15 seconds. That should work fine. You could make histogram, you could divide the module into as many things as you want. Just gonna read results. So here I'm gonna, once again, read results UI. It's gonna be a function of ID. I'm gonna bring the namespace, ID, and a tag list. And right here, I'm just gonna put a data table output. Under the namespace, it's gonna be results. And on the read results server, function of ID, module server. So the ID will equal the ID, and the module will be a function of input, output, and session. And what I'm going to do here is I'm going to set a timer, which is going to be a reactive timer for 15,000 milliseconds, so 15 seconds. And what I'm going to do is here and observe. Okay, so I'm going to observe timer. So every 15 seconds, this will be executed. And I'm going to create a reactive values. This will be data. Data will be equal to reactive values. And here, this will just have a data frame, an empty data frame. And this will be equal to results. So every 15 seconds, so I'm going to data temporary will be equal to download df, and project URL will equal, let me put it right here, URL will equal sys.getEnvironment db URL. So project URL here is going to be equal to URL. And file name will equal polls. So now this, I can actually set it into a feature. Yep, so now let me do this. Data results will be equal to a feature in which we call the download function here, like this. Let me just do this then. So now this is the feature, right? And actually, I'm gonna put this here. This should work. This should work as intended. Now I replaced this here, and this I should be able to use this. No, I'm just gonna do this. Yep, this should work. This should work as intended. I'm just gonna put this here, and the timer I'm gonna put it after, so that it does it the first time. No, this shouldn't go on the feature. There you go. My bad. Okay, so this observe should be updating data results every 15 seconds. And now I'm just going to do an output results will be equal to render data table. And here I'm just going to have data results. If I'm not wrong, now I just call this on the server results and on the UI. So read results UI results. If I run the app, it should work if I'm not wrong. I forgot a comma. There you go. There you go. So look, there are the results I put earlier. If I just call myself John Smith, age 45, height 177, favorite color green, in 15 seconds, or in a couple seconds, the result here should be updated. If I, there you go, there it is. And here I have it on my real-time database. So this is pretty scalable because no matter how big this is, this will run on a separate thread. So it's going to be quite easy to download. It would take like a little bit to render because it's using server-side rendering, but it shouldn't be that big of a deal. If Firebase is slow, again, this is run asynchronously, and you can develop two things side by side because you're using modules. So that's pretty much it. All the code for this is going to be on GitHub. I'm going to get in it later. Yeah, look how clean the code is. So our UI is just 10 lines. It could be less, like you could literally put this into less. And our server is literally just 2 functions. So I think this is quite clean, and I hope this tutorial will help anybody out. I had a little bit of trouble learning this. I think the resources online are not that mature yet. I know Hadley Wickham is working on a book, and that helped a little bit, but I think this is a pretty good example. So yes, thanks for watching. Check my social media on the description if you need any contact.